we are going to take one step forward with that idea of parallel versus perpendicular and start talking about systems of equations for our 3 days of 2.3.
So today we're going to talk about systems of equations: consistent, independent, dependent, and inconsistent. So when we talk about systems of equations, it's two equations solved together.
It could be 3, but in the purposes of this class, we're not going to get into 3 because the last time I tried to teach 3, I think my head almost exploded.
Then we go into consistent, which is the system has a solution. And then underneath that subcategory of independent, exactly one solution, the line intersects.
And the way I like to remember this is when you are independent, when you get out of high school and you move out, you are independent. You are the one person you have to worry about, unless, of course, you by that time happen to have a child. Hopefully you do not, because you're a little young, but that's another story. So if you're independent, you have that one person to provide for.
Which must mean that dependent means infinite number of solutions. Lines lay on top of each other.
And the way I remember this is that your children, when you come down the road and have children, like my children, they are dependent upon me. Food, shelter, money, etc. And so the reason why they lie on top of it is it's like I am carrying them.
And then we go into inconsistent, which is no solution. Lines are parallel.
And we call it inconsistent because we say it's inconsistent that they could work together because they don't ever touch or meet with each other.
But before we make your head spin, we came up with a simplicity way of looking at this of a flow chart.
First thing you want to do is ask yourself, do they intersect? Well, yes, no. If yes, it's consistent. And then you got to ask yourself, do they intersect once? If yes, then it's independent. If no, then you want to know, are the lines on top of each other? If yes, they are dependent. If no, then you made a mistake and they're actually independent. Now, when you asked if they intersect, if you said no, then that means that they're inconsistent. And so if the lines are not on top of each other, you made a mistake. Either it's independent or it's inconsistent, but it's not consistent, dependent. So now that that has all in your head and your head's probably on the verge of exploding, let's try some examples. So our first one says we need to graph these two equations and then find if the solution, if it exists. So I go ahead and I graph them. So I have y equals x minus 3. That means I have a y-intercept of -3 and a positive slope of up 1 over 1. And I'm going to go every couple just to spread out the dots. And I can go ahead and draw my line. Then for the red line, I've got a positive 5 for a y-intercept and a -3. So down 1, 2, 3, 4, 1, 1, 2, 3, 4, 1, 1, 2, 3, 4, 1. So now I can go ahead and draw that line. Now, as I can see, they cross. That means, because they cross, that means that they are consistent. It's consistent with the fact that we do have a solution. And because they intersect once at this point here, that means that they are independent. And that solution then is going to be the ordered pair 2, -1. Now in the coming days we'll teach you how to do that mathematically, but right now we can graphically see that they intersect. The next example, I see I don't have them in slope-intercept form, so that's the first thing that I want to do. So the first step is to get them into slope-intercept form. So I'm going to go ahead and solve this one. I'm going to subtract 2x, and that gives me y equals -2x plus 3. The next one, I'm going to subtract 3x, and that gives me -2y equal to -3x plus 8. And then I'm going to divide everything by -2 to give me y equals negative divided by negative is positive, so 3/2 x minus, because positive divided by negative is -4. So now I graph. So positive 3 with a slope of -2, so down 2 forward 1, down 2 forward 1, and draw my line. And then in red, I go -4, and I go down 3, 4, 2, down 3, 4, 2. I can see, here's where you guys get mad at me. I can see that these are going to intersect because they are getting closer to each other. They just don't intersect on the graph. So I'm going to draw them down. I'm going to, for the sake of today, not make you find this point of intersection, but the point of intersection is right here. So this case you can say that they are consistent, and I'm going to abbreviate with consist, and independent. Agreed with indep. Now, third piece for today, or second if you will, I'm giving you a system of equations and giving you what I'm telling you should be a solution. You need to tell me, am I right or am I wrong? Which all that means is I need to substitute in that 1, 3. So x is 1 minus 3 times 3 equal to -8. So then I need to solve this because I don't know if that's true. 3 times 3 is 9. 1 minus 9 should equal -8, and it does. So -8 equals -8. That tells me that so far it's correct, but it has to work for both. So then I have 3 times 1 plus 2 times 3 should equal 9. 3 times 1 is 3. 2 times 3 is 6. 3 plus 6 should equal 9. It does, in fact. So I do want you to go all the way until you hit that 9 equals 9 to show that you are correct. And don't just write it for the sake of writing it, because it might not always be true. So you would say then for your answer, yes, 1, 3 is a solution, and you can abbreviate solution SOL. So now we're going to go ahead. You got first one you have to graph. Please make note they are not the same equation because the pluses and equal signs are different. And graph them, identify, classify it, and if there's a solution, tell me what it is. And then also, if you have this set of equations and this solution, is it a solution? And as always, make sure you're using ClassMeet if you have any